Hi everyone, in this video I'm going to be demonstrating a quick walkthrough of setting up AIStore in Kubernetes using our latest Helm charts. First, I'll assume you have Kubernetes set up with access configured to a cluster. As you can see here, I already have a 3-node cluster configured. We'll be using node affinity rules to tell AIStore which nodes it can run on. Here you can see that all 3 nodes are configured to run both proxy and target AIStore nodes. Next, let's take a quick look at the disk setup. Logging into one of our hosts, we see 16 NVMe drives, each with 5.8 terabytes of storage. We provide some Ansible playbooks to help configure disks properly, but in this case I've already run those for each node, so each drive is already formatted with XFS and mounted to /AIS. We'll make a note of the mount point and the size for configuring AIStore's underlying storage later. Finally, let's check out what we have running on this cluster. Initially, you'll notice we don't have any pods running outside the kube system namespace. We also do not have any namespace created for AIS or the operator. All deployment in Kubernetes is managed by our AIStore operator. We deploy a custom resource, and the operator manages the entire AIStore lifecycle. You can add the operator Helm chart repository and install it directly, but it does have a dependency on Cert Manager. So here, I'll show using our provided Helm file to easily do it in one command, with an included install of Cert Manager's own Helm chart. Now Cert Manager and the AIS operator are both running, and the operator will turn any AIS custom resources that we create into a functioning cluster. We just need to define the right values for that spec, so I'll do that now. Currently, our AIS Helm charts are only hosted locally in our GitHub repository, so to run the deployment, we can start from the provided example config and Helm file. If you haven't already, clone our Kubernetes GitHub repo. Inside the repo, locate the Helm file in the helm/AIS directory. Now, I'll create a new environment to control deployment-specific variables. For this example, I'll set HTTPS enabled. Next, we need new config files for each chart in this environment. The TLS charts set up a Cert Manager issuer for issuing self-signed certificates. You'd probably want to set this up with a real certificate authority, but for our case, it'll give us a way to just do it all locally. Before running the deployment, we need to set up the authentication for any cloud backends we want to use. First, I'll create a namespace. Here, I'll simply create a Kubernetes secret containing my local AWS credentials. Checking the cluster, we can see the secret is created. Now we're ready to configure the values for the AIStore Helm chart. The first section contains details on the Kubernetes nodes and general config, node names, desired namespaces and cluster name, and finally disk configuration. We'll update this with the info we saw earlier from the host. Next are a few options to change for the AIS cluster. I'll set the size to 3 nodes and enable TLS with the location of the certificates to use. I'll keep the images for our pods as the latest releases, and we'll add cloud support for AWS by telling it to use the credentials from the secret created earlier. I'll leave all the options below that at their defaults for now. With the config all set, we can simply run Helm file sync with the specified environment, and the entire cluster should come up according to the spec. It will create namespaces, persistent volumes and their claims, stateful sets, all required volume mounts, and eventually the AIS pods themselves. We can watch the pods become ready in the AIS namespace, and once they're all ready, we can go ahead and use the cluster. To connect to the cluster, you will need to have direct access to each of the host machines. To make it simple for this demo, I'll just SSH into one of the hosts themselves. I already have the AIS CLI installed, so I just need to export a few environment variables to configure access. First, I need to get the CA cert for the cluster certificate so that the client can verify the cluster certificate. You wouldn't need to do this with a trusted CA, but it's necessary since I'm just using a self-signed one here. Next, I need to set AIS endpoint for the CLI to use to actually connect. Finally, we can access the cluster and test it out. I'll quickly check the cluster map and the current config. Now I can add objects to a new bucket and get those objects. We can also view and get objects from any backend buckets. Once pulled, those objects will be accessible locally from the cluster. Of course, there's a lot more features available, but that's all it takes to get started with the full production level deployment of AIStore. We're continuing work on the deployment process to make it as easy, secure, and configurable as possible, so some things may change. But just getting started is very simple and can unlock scalable performance with very little required. Check out the rest of our docs on GitHub and on our blog at aistore.nvidia.com.